Hi everyone, thank you for taking your time. In this video, I'm actually going to explain about one of the interesting projects about classifying the species of iris flowers based on a set of machine learning models. I'm currently using a Google Colab notebook where I import all the libraries along with making machine learning predictions. Since we have three different classes in our data, which is Virginica, Versicolor, and also Setosa, we would have to consider this as a multi-class classification problem. Therefore, it is nothing but not a continuous problem, but it is actually it's not like a regression task. This is a classification task. In the case of regression tasks, we do have continuous variables like, for example, house prices, which are continuous. But in the case of classification problems, we actually take a look at different categories, right? In our case, we do have three categories: Setosa, Virginica, and Versicolor. Therefore, this is a classification problem. Now, the first thing that we do is before we start this project is import all the libraries. Let us now import those libraries and get started. We just say import numpy as np. We just say import seaborn as sns. Uh, Seaborn is actually used for data visualization purposes. We can also say import matplotlib.pyplot as plt. This is also actually used for visualization purposes. Now let us also import sklearn and use various modules from that. So from sklearn.model selection, import train test split. When we are doing machine learning, we have to divide the data into two parts: training part and the test part. We train the model with the training data, and finally we predict using the test data to see how well the models are actually performing. Therefore, we use this library from sklearn called train test split, which will divide the data into two parts. Now we'll have to actually download the data or take a look at the data, which we can actually take a look at from the sklearn library itself. I think sklearn, this there should be sklearn. Okay. Now let us say from sklearn dot data sets import load iris, right? Now what we basically did was we imported that particular data set, which is load iris, and let us read it for now. So let us say iris data equals to load iris, which is nothing but we are taking a look at, we are creating an instance so that we can access the data. Now we just take a look at the input training data, which is nothing but iris input, or we can maybe just call it as data equals to iris data dot we just want to access the data from that. Now we also need to access the target variable, which we do it by saying that iris data dot target. Now we have the data which is present here. Here we do have the sepal length, sepal width, petal length, and petal width. These are the four features which we'll basically use to predict the target, which is whether it's versicolor or setosa or the other category. If you want more information about this data, you can easily just go ahead and say iris data dot descr to get an understanding. Oh, looks like this format isn't that good to read, so you just say print of that so that you get a very good representation about the data. Here we have considered four features like sepal length, sepal width, petal length, and petal width, all of which are in centimeters. And finally, we are determining the class, which can be either setosa, versicolor, or virginica. We take a look at the minimum length of each, the maximum length, what was the mean, what is the st, which is nothing but the standard deviation. Similarly, the correlation with the output variable. Here is a lot of description about the data. You can actually go ahead and read it if you are more interested about it. And here we see how this actual data is. Now let us perform our machine learning tasks. Now we have the data, but we need to actually divide the data into two parts. For that, I say that X train, X test, Y train. I just say Y test, train test split. This is the library that we already had. We give an X, we give a Y, we just give the test size. We just want the 30% to be the test data, and the remaining 70% to be the training data. And then we just say random state equals to 101, which means that the same type of split takes place when we again rerun the cell. Yeah, if we give a different random state, we'll be getting a different split. Therefore, we'll have to take a look at different splits and finally get the output. But before that, let us also, I haven't yet taken the X and Y variable. Here we do have this data and target. Now let us just say X equals to data and Y equals to target, which we have earlier pointed out. And now we run that and then we divide this data. Let us take a look at the shape of the training data. Similarly, we take a look at the shape of the test data. We do find that we have 105 instances or 105 measurements and 4 features, and this is the test data. Now we'll have to use various machine learning models. Since this is a regression, this is a classification task, we would be using various classification models like logistic regression or a few other models like naive Bayes, depending on the situation. Here in our case, since this is not a very complex problem, we will use a logistic regression and then try to solve it. Okay. So I just say that from sklearn dot linear model import logistic regression. I think this should work. Okay, we have taken that library and now we just say initialize that. We just say logistic regression model dot fit. We just say X train, Y train. Here we give the training data as the input, we train our model, and finally we get the predictions, which is nothing but model.predict X test. It is important to note that we also have the output for the Y test, because for the test data we have the input along with the output as well. Therefore we can also measure how well we are actually doing. Let us see now. We have run it, and now let us just look at the Y predictions. These are the different categories, with 0 indicating setosa, 1 indicating virginica, and 2 indicating versicolor. These are the 3 different categories. Now let us also take a look at the actual test values, and these are the actual test values. Now it is important to monitor how well our model is doing, not just on the training data, but also on this test data, which the model hasn't seen before. Therefore, we import various metrics, like from sklearn dot metrics import. I think it should be accuracy score. Which will basically give us how accurate we were in our predictions. We just say accuracy score of Y predictions and Y test. This gives us 97%. So if I just convert it into our scale, which is nothing but we were accurate about 98% of the times. Therefore, we did a very good job in classifying whether it belongs to any of these categories. But it is important to note that when we actually do data science in real life, we might not get these numbers, because real world data is always like it's not in the right format, or there are a lot of missing values, and also there is a lot of uncertainty, or there is no correlation between the features. Therefore we cannot expect generally this kind of accuracy on the real data. But I would say that if we do feature engineering quite well and use the best models along with hyperparameter tuning, then I would say that we can reach around 85 or 90% accuracy, which can also be really useful, especially when we are considering the business use case, where it can save a lot of profit. I mean, it can generate a lot of profit, which can in fact help us build the best models. Thank you so much for tuning in. This is about how we actually do the machine learning. We import libraries, we just take the data, we just divide the data, finally use the best model. And the last thing is to get the accuracy. We do have other metrics like F1 score, recall, and precision, which I'll highlight in the future videos as well. But for now, this is about how we basically perform machine learning. Thank you so much, and have a great day.